make this formal. We're reviewing the ASTM D8071 detailed ILS operating instructions. The major steps are setting up your GC and your VGA, and then performing the validation of your samples. And we realize that some of the participants will have auto handlers that can hold all of the samples in one tray, and that some participants have auto samplers, that can only handle either 8 or 16. So in the instructions we have differentiated those two workflows. From time to time, I'll go ahead and bring the presentation over here for you all to look at as we go along. But I want it to be more fluid, as if I was there and we were looking at your software on your desk. And as I mentioned, we will be sending this out to you all shortly, most likely tomorrow, midday or around lunchtime. So we've sent samples to everyone, including some samples that are not part of the ILS that we're reviewing with you all now on getting your system up to just installed status, and that would be the CS2, which is for the wavelength check. And we're having you run some ethanol just to make sure there's no reactivity present in your system. But once we've completed those checks and you start your ILS, the first step will be, as many of you have done Piona before, the first step will be to set up VU Vision to be able to acquire samples, and then to acquire some system samples so that we can qualify your system as ready for ILS samples, and then to proceed through acquiring the ILS samples. You should have already received 54 samples. So those are the actual samples themselves, and we'll be processing those in 4 batches of 16. And if you do the math, the last batch is not going to be 16, but it's 4 batches nonetheless. And you can run them on different days if you have the smaller trays, or run them all in one shot if you have the large tray. Prior to each batch, you'll be running validation samples also. And these are the same validation samples we're using to perform system validation. So just to repeat, we're going to start by validating your system, and then we'll run the samples. So there's a little bit of administrative work to be done in preparing, and one of those is the process of setting up a location on your computer to store all of the samples. So I'm asking that you create a directory with this name, D8071 ILS. I like to put a 0 in front of it so that it auto sorts the folder to the top of your C drive so it's easy to get to. And within that folder, let me move these, within this folder I'm going to ask you to create 3 folders. One for the system validation samples, which is the first major step. You're validating your system. The second one is the sequences and methods. That will just be to store your sequence methods and your acquisition method files. This way you don't have to look all over your hard drive to try to find where you put them. And then the most important one, of course, is the ILS samples. This is where you'll be storing your samples as you acquire them. I want to show you another picture of that. So this is without all of the extra folders that I have on my computer. As I mentioned, a top level folder to hold all of the subfolders. If you put a 0 in front of it, it'll auto-numerically sort it to the top. and 3 logical groupings, the system validation, the ILS itself, and the sequence and method files. The text on these slides is what we're talking about here as we go through this presentation. So don't pull that off. So let's proceed to system preparation. You've got your computer organized now. You know where you're going to put your files. Everyone participating is assumed to have some operational familiarity with both VU Vision and VUV Analyze. Nonetheless, we're going to go into some detail, so if some of this seems old hat to you or a little bit slow, please bear with us. We'll be sending you an acquisition file. All of you have performed acquisitions before. As we see along the top here, the workflow and the acquisition method. Here I'm going to load up the file that we're sending to you. It popped open on my other screen, so I'll just go ahead and load that file. I might as well go through. There we go. So when you receive the file, I would ask that you place it in the sequence and methods folder. Here we see all the settings have been made for you. In our instructions, we give you a copy of this so that you can validate and make sure that they haven't changed, or for some reason you have lost them, they can be re-entered. You see 4.5 hertz, the triggered acquisition. The starting pressure is 0.30 psi. The filters have been set for you, and the actual details of the method are also typed in here. As you all recall, this is just notes, does not control the system. We're going to talk about this system pressure in a little more detail. Some of you have previously worked with us on this method in the pilot or performing work with the VUV Analyze in the past. And previously we used the split ratio of your GC as a method for tuning in the response of the system. Going forward and written into 8071, we'll be using the makeup gas pressure. In short, we run a sample, we look at the response, the VUV Analyze tells us a suggested new pressure, we run it again, and 9 times out of 10, most of the time, that response will come in on the second run. That's the short version, but we'll go over that in a little bit of detail as we progress through this. I bring that up because it is the departure from what we've done previously, and this is an important part of tuning in the response here in the system verification. I'm going to come back to home. So we've set the acquisition. We will not be using peak or target tables or quantitation methods. We'll strictly be creating sequences. So coming back up to the top level, we're talking about the system preparation, verifying your system. So we want next for you to set your GC, and we are providing those GC settings for you. So here in the presentation, and now you can read these directly out of the method. All of this is straight out of the method, but we put it together in a convenient organization for you. I'm going to back up a little bit in the presentation. Here we are. The GC values are here. It's helium carrier only. We're using constant flow method. However, some GCs are not able to have the constant flow mode. In that case, we'll be using the constant velocity mode. Here we have the method for the GC. This is also in the acquisition method as notes. And we like to give you a reminder, these are the most common errors we've seen in our work. The ratio is not set correctly, the mode is not set, the nanoliter injection is set to on. Some people are not aware of this setting, so it could catch you by surprise, especially if you're using the front panel as your mode of GC operation instead of chem station or open lab, something like that. The vacuum compensation should be off. And here we reiterate using constant velocity mode. Do not use constant pressure mode. It is for the GCs that don't have the constant flow mode. Now, in addition, we talk a little bit about preparing your VGA detector. And one thing that we ask you to do on that end, not on the VGA itself, is to close View Vision. Maybe you've had it open for a couple weeks. Maybe for some reason you don't have it open, but we'd like you to close the software, let it shut down, and then start it up again. And always as a reminder, you need to wait at least 30 minutes for the lamp to stabilize. And we have here the settings also for the VGA. So again, we're at the beginning where you're preparing your system to be validated. You've got the acquisition method you'll be using to acquire. That acquisition method will be used for the validation samples, and it will be used also for all ILS samples. We've kind of looked a little bit at how the VGA, what the VGA settings are, the method, and the GC settings. So I'd like to return now to View Vision, or we just call it Vision. We talked about home. From the home screen, we talked about the acquisition method. In order to validate the system, we need to run a series of samples. And we'll be starting with a blank sample. Then we'll be running a VUV-RI sample. The retention index is RT for retention time. And then a VUV1 sample. Now what I'm asking is, or what I'm providing I should say, is a guide for you all to name your samples in such a way that it's easy for all of us to find the samples and keep track of where we are. I skipped a few slides. They were just showing you how to do the acquisition method. We were doing that fluidly with the application itself. But you'll see in most of these slides that we've used a generic name for the company, Acme Labs. And for example, while we're working on system validation, we'll use the name either verification here, but validation, and the name of the samples, the blank, the RT, and the VUV1. So we've seen this before. I'm just going to create the sequence here. I find my method here where I wanted it stored. We're not using a quant. The format stays the same. The selection of where to store the files we've set up. We're not doing the ILS yet. We're still doing the system validation. So we just select current samples. You see there I already have some data, but your file, of course, will be empty when we first start. And then we'll put in the names. I'm just going to call it lab, verification, blank. Similarly, it would be lab, your company's name, in other words, verification. That's the step we're on. We want to separate these verification samples from the ILS samples, the RT, and then lab, VUV1. Of course, since you're all familiar, we have to use the sample type. I'm going to save this. And I'm just overemphasizing the data location. When you're done and you're finished this process, it'll be very simple to zip up the top level folder and put it into box rather than to have to hunt down the location of where your files might be.
Easy to process data too.
Yeah, it's very easy for us to process data. So, of course, I would submit to the queue. I would acquire these 3 samples. And the result would be in that folder that I would have my first folder created. Here you can see I have 2, and as I mentioned earlier, we're going to be running 2 samples so that we can adjust the makeup gas. That's why you see 2 here, but when you do your first acquisition, you'll see here that you have the 3 folders, the 3 data files, the blank, the RT, and the VUV one. Some of you are probably familiar with these little files that pop up whenever we open these files. They wouldn't be there. I've been opening and looking at these files earlier today. That's why those are there. So the next step, we've run the files. So we're going to start using VUV Analyze. Let me open that for you. Now it may not start its opening on the screen here, but we'll see. We'll try to get it to do it for you. So the version we'll be sending out is VUV Analyze 1930. Now when we're finished looking over the ILS, I might show you a few of the new features that VUV Analyze has. They're not being used during the ILS, but you'll be excited to see these new features. They're pretty cool stuff that we've added in. So we acquired the samples. We used the acquisition file that we're providing. We're using kind of a somewhat strict naming convention in our sequence so we can keep track of the names of the files. Then we're saving them to specified locations in Windows using Windows Explorer and the little directory we talked about. So these are the 3 files. So the first one I'm going to do is show you the new front interface. Previously there were multiple tabs here. They're still here. They're just hidden out of view. And this is production mode. You all, some of you are familiar with using production mode. All of the engineering work's been done, and your team members only have to place the run files into here or a directory and batch process those files. In the instructions, we give you the secret key. Oh, here we go. So I entered into setup mode. Control-Shift-S for setup. That's all written out in our instructions. So this looks a little bit new, something different than we've had in the past. And for the ILS, we're making it as easy as possible so that you don't have to go into any of the research and development mode. So I'm just going to pull it up to show you that it's still here. That familiar multifaceted interface where you have multiple files, you have all these settings here that have to be set, some reverse search information. So what we've done is we've put that all in as default for D8071. When you're not using D8071, you'll be able to go in and change it to what you want. But for in terms of the ILS, we're just using the Setup tab. So like many of our softwares, it's top-down, left-to-right workflow. So we're going to start by opening the reference library that installs. As usual, in the demos directory of VUV Analyze, you'll find this is the official name of the library we'll be using. It's also the library you'll be using going forward for your use of VUV Analyze on other work other than D8071. The library has been cleaned up, some analytes have been added, a few probably been removed. We're very satisfied with this library. This is the one we'll be using. Now, back to the flow of the ILS. We've just run our first 3 acquisitions for the system validation. I'm going to open the RI file. RT. I use RT and RI a little interchangeably. I should probably be a little more strict. The retention time file to create the retention index file. You all might recall that in previous work we would run VUV1 and we would search through VUV1 and do some peak counting and make sure that we had the right analytes and put the times in there. It was quite a process, and it was easy to mistake values or put in the wrong values. So that's why we created the RT mixture. It has only the peaks that we're interested in that we use as our markers, as our retention index analytes. So we can simply run VVRT. You'll be able to do that in the future for other work that you might be doing. And we press the Create RI file, give it a moment, zip through it, and it pops up the retention index file. This is usually where everybody starts clapping. Well, anybody that's had to battle the RI file. So the work is done. We can close that. By the way, here's the name of it. And here you see in the Setup tab, it shows you where that file is stored. And generally speaking, all of our report files are stored in a subdirectory of the location where the file itself was saved. So top down, I created the RI file. Now I'm going to create the production file. It tells us it was successful. I'm going to change back to the production screen, and I'm going to look at the date and make sure, yep, that's right now. So I'm in my production file. All of the settings, all of the parameters are the D8071 parameters. We don't have to go change them. And what we've done with the retention index file is we've added those values to this production file. It's a little bit of a misnomer because there is no file that you have to deal with. You don't have to store it, save it, wonder where it is. VUV Analyze keeps track of that for you. Just for your information, you can have your own custom production file when you're not doing D8071 work. So moving top down, as you recall, we got our system together, we got our GC in good condition, we set our methods, we acquired our 3 samples of blank, we've processed now the RT, now we're going to process the VUV1. It's kind of why we had you run all 3 at once. Here's my VUV1, pulls it up, and I'm going to calculate the response. Previously, you've analyzed gasoline files or gasoline type files, and this is kind of the standard process we go through. And you're all probably familiar with the format of the report as it was previously. Since this is a calculate the response functionality, the report is a little bit different. This isn't your standard results report. This is the report for setting up your D8071. I'm going to open it up a little bit. As a lot of our files have, there's some metadata at the top, and then we've clearly put easy for you to read the status. And the overall status is fail. In order to understand what failed, you have to scroll through the data. Here you see the categorization of the classes and the individual analytes. They've all passed, so that's kind of nice. Here we're looking at the individual carbon mass numbers. The columns are a little bit offset because this is looking in a text file. It's just information for you. And here we have some baseline checks now that are running. They all passed. But down here, the benzene response has failed. And so all of you have been through the process with us where we set the split. We run VUV1 a few times. We were doing what we called a reverse lookup. We were looking for a value of 1 of the benzene response. So we've made that so much more simple now. You run VUV1, it measures the response, and it tells you if you passed or failed within the expected high and low ranges. Here's the measured value, 2.85. We expected 3.5. Here's the range that it can be. a little bit of verbiage here, just repeating what we said. And we're giving you a suggested makeup gas pressure to use going forward. Now, in all of our instructions, we're telling you that we're starting with 0.30 psi. Here, this data file is a little bit dated. We'd actually started with 0.35, but for the D8071 and in the instructions and in the method that we send to you, you'll be starting at 0.30. But now it's telling me, oh, here's the new value you should use. So I'm going to close this. We've processed the 2 files that we just acquired. We didn't do anything with the blank. We're going to go back over to your method, Envision. We're going to update the choice. Save it. Here we are in the location that we already gave ourselves to make life easy. We're going to overwrite it. And we're done. What do we need to do next? We need to just acquire a single
We're going to do the R key again. Same thing.
But I say do it with the QC once we pass. Or you want to go through the whole thing? Okay, yeah, sorry, little blank there, little bump on the record. So we set the new acquisition file, we saved it, we came back to our sequence. We don't have to do anything here. We're going to just run the same sequence again, a sequence of 3 files, submit them to the queue, acquire the data.
The blank would be optional, I get you now.
So we've come to an executive agreement here that, by the way, you're the first run of our get-together. We've come to an executive agreement here that the blank could be optional. So you could remove it, especially if you're just if you've just run the acquisitions and you go immediately to the analysis. You saw that analysis in VUV Analyze about 5 minutes at the most. You can come back, acquire. If you have to walk away or wait till the next day for some reason, hopefully not, you might want to run the blank again, but the blank could be optional. Nonetheless, you've acquired the data again, and as you saw in my directory, I've acquired the data a second time. So I'm going to go back up here just to keep the theme. We've been storing in the system validation samples. Since we use the same name, it just created a new folder with an appended number on the end. This should be something that you all have seen, having run Vision multiple times. And inside here, we have the files. You don't see my VUV1RT, so the demo is not the most well organized at the moment. But you've acquired your second set of data. You come right back over to Fiona. Now, if you did have to close it, you would have to open it up again, acquire the RI file, and then create the production file, and then load the new VUV1. So most likely you'll do this in order in the same day. So you would see this as I have it here. I'm just going to change the VUV1 file. I'm going to go up a level, grab my second file, I put it in there, and I'm going to calculate the response. So I'm going to ask you to use your imagination here, just a little bit. I'll explain that. So you get your second file, second results for calculating the response, and for whatever reason, they gave me this data file and the baseline failed. But we see now the point we're getting to is that your benzene response now passes. It measured at 3.48. That's pretty close to what we wanted, and you're ready to move forward. What we found is that starting with the 0.30 psi makeup gas, if you're not in range starting, which is, it's very likely that you might not be in range. After one run and one adjustment, you probably will be in range. If you need to run it a third time, that would be fine. If you run it a third time and it still wants you to run it again, you're still failing, we'd ask that you contact us. That would be very unusual. In addition, if for some reason it were to project a new makeup gas pressure that's outside the range, it will give you a warning, in which case you would give us a call. So we were on slide 16, and in this document that we'll be sending you, there's quite a few slides that take you through what we just looked at. And so I'm going to skip all those. Yes, sir.
Can I ask you something?
Yeah.
What about the relative response factors?
What about the response factor?
Yes, because I remember that before in the view analyze you had to insert a text file about the relative response factors.
Yeah. So let me answer that question. Federico is asking, for those of you who have done this multiple times in the past, the benzene response used to be a response value that was in the report. So we've moved away from that completely. But just let me remind everybody of what you're asking about, just to make sure I understand. Previously, you would come to the response, you'd look at the benzene, and you look at its value.
Federico, I think you're asking about the response factor file, right? That used to be there?
Yes.
Okay.
Yeah, so all the that's part of the brand new library, how the library has been changed. The response factors are now embedded into the library, along with cast numbers, along with density numbers, along with a bunch of other information that in the future will let us do other applications like detailed hydrocarbon analysis, for example, with calculated parameters. So that's one of the big improvements of the library that Mark was talking about.
Yeah, so usually here we would get a round of applause too. You don't have to deal with the RRF file on all the tabs and the spacing and all of that. And when we're done with this ILS, I'll show you how simplified that has become. So certainly for the ILS, you don't have to deal with the RRF. Thank you, Dan. Let me pull this up and we'll continue forward. So if for some reason the suggested makeup gas pressure would be outside the range of lower than 0.1 psi or greater than 0.6, you'll get an automatic warning. In that case, we ask that you call the ILS coordinator, Dan, myself, or Daryl, and we can talk it through. Usually, if by the third time you're not getting a proper response, we need to go back and verify all of the settings, the GC settings, and of course if they were off, we would just start from the beginning again. And if everything seems correct and we still can't get that right, we'll go into some detailed discussion on what might need to be done to resolve that issue. It's kind of hard to go into all the possible corner cases that might occur, so that's why we're kind of using the generic, give us a call if it doesn't come in. To date, we haven't had a problem with this, so we're not expecting it, but we just want to cover our bases. So we've done a bulk of the work, and we're already halfway through the presentation. And what we've been doing is system verification. We've been running above 1, and of course we had to run an RT file first so we could get our RI indexes to be able to analyze the above 1. We've analyzed it. We maybe had to run it one more time to get the proper response. And once the response comes in, everything's looking good. All we have to do then is to run the RT one more time to get a final RT. Because we're changing the makeup gas pressure to get the benzene response proper instead of messing around with the split, because we're changing the makeup gas pressure, we want to run the RT one last time to make sure that we have the closest value for all of our markers. we found that you probably wouldn't, the change is going to be very small, but just to be proper about it, we want to run RT one more time. You just come back in and process the file. So you'd run it one more time, load it up, and create it, and then create the production file, which is just pushing a button. And then we ask, I lost my mouse here, pardon me. And then we ask that you run one of the VUB-CS samples. We've included 4 validation samples to be used throughout the ILS, and we use them here in the system validation, and then we'll run these 4 prior to each of the batches. One of them is a blank, a DCM blank, methylene chloride blank. Then we ask that you run the RI file, the VUB1, and the VUB-CS.
Can I say something?
Yeah, go ahead.
The methylene chloride is not included in the package, so the labs need their own methylene chloride.
Yes,
or desperately carbon disulfide.
Yes.
But methylene chloride is, and the CS is a check sample, and that is, the method is written, you can either run a QC sample or a check sample that has known values. So that's just a gasoline that has known values.
So we'll be having you run the CS samples, but we will not be performing an activity on them. That will
because the ILS will define what those known values are.
So in the future, after we've passed our ILS, you will be using the check standard moving forward, but this work here we're doing is defining those values, as Dan said. So this is a good break point to see if there's any questions. In the flow of the work, we've validated the system, and we're just about ready to start acquiring samples. Let's see. All right, I'm going to continue moving forward. Sorry, those got out of place. We've talked about this. So yes, so now we're going to acquire and analyze the samples. And I want to remind you that we discussed earlier, there's going to be 2 workflows. One workflow where you have a tray that can handle all of the samples at once, and one workflow where you have a smaller tray that can only handle 8 or 16 samples at once. We're talking again that there's 54 ILS samples, and prior to each batch of 16 is the most you can have in a batch, we have you run 4 of the validation samples, a blank, an RT, a CS, and a VUB1 in that order. For those of you that don't have the large trays, we'll just call them large trays, you'll run the 4 samples and run a verification on VUB1. And then run this, if it passes, which we expect it to, run your 16 samples. You may have to run them in 2 batches of 8. We discussed a little bit in here the naming of the samples as you put them into the sequence. I'll show you a picture of that, but using B1 through B4 as the batch number. But each sample itself will be uniquely numbered, so you might have batch 1-1, batch 1-2, and then batch 3 might be 37, along those lines. We discussed a little bit of the common practices you all have, just as a reminder, refrigerating the samples, only opening the ampules one at a time, and only for those samples that you'll be immediately acquiring. So if you're doing batches of 8 or 16, just open 8 at a time or 16 at a time as you create those batches. The crimped cap are mandatory, and we want you to fill them to approximately 50% of their capacity, and then store the remainder as with a crim cap also as bulk, and just be sure to label all the vials so that if you need to run them again, you can. Here we're just discussing in detail that there are two workflows, a large tray and a small tray. So we've talked about that enough not to read these verbatim. This is more detail. So as you come back, you'll be able to look at this and remind yourself, oh yeah, I've got a large tray, I'm going to run them all at once, or I've got small trays, and before each batch, I need to run my 4 samples and verify the VUB1 still has the proper benzene response. The main reason for that is that for those of you running 8 or 16, you'll likely run that a batch a day, and then the GC will sit overnight kind of in idle state. So in the morning, when we run the 4 verifications, we want to make sure that all moisture gets pushed out of the system, and that we think that that would be the only issue that could occur. So that's why we have you verify the VUB1 prior to starting those 16, because if you do have a baseline problem, it would be easier to run a few more blanks and clear that out than to scrap a whole batch. Those of you running the large tray, that concern of moisture coming into the system is not there because it's running constantly throughout the full series of samples. We do go into detail about the naming convention. We have several screenshots. Excuse me. I ask that you name them. So just to be clear, we're looking now at the workflow where you have a small tray. We ask that you use your lab name that you put down if you're in batch 1, batch 2, batch 3, batch 4. Previously, when we did system verification, we put the word system verification there, and then just the name of the samples. They're either blanks, RT, VUB1, or CS, or if you're actually running the samples, you would just say sample number 1, sample number 2 through 8, 9 through 16, and so on. And then a little bit of attention to the sequence naming so that you tell us these are the verification samples for batch 1 or the verification samples for batch 2, etc., or the ILS samples 1 through 8, ILS samples 9 through 16, etc. If you have a 16-slot tray, this would say 1 through 16. You only have to use 1 tray to do 1 batch. If you have the 8-sample trays, then you have to do 2 sequences to run a full batch. All batches are preceded by the verification samples. Here, I'm just giving you the details that we all know. As I mentioned at the beginning, we put a lot of detail into this presentation, detail that you all are relatively familiar with. We focus mainly on the naming of the batch, the output directory, and then the name of the sequences. I'm not going to repeat them multiple times in this presentation, but we do repeat it multiple times in the printed presentation. When as you recall, we're talking about the small tray process. By the way, who does have trays that can accommodate up to 70 or a higher number of samples? If y'all could just type in a quick yes or no. Thank you, Todd.
And no, I think that we have a maximum 16 vials spaces available. Okay.
So I'll spend a little more detail on this portion. As I mentioned, we'll be running 4 batches, and at the beginning of each batch, we run 4 validation samples. And prior to starting your batch samples, you have to verify that the VUB1 still has the proper response. If you're opening VUB Analyze, you come back in the next day and you get started and you close VUB Analyze, you'll want to open your original RT file again and process it so that you can then put in your VUB1, run it, and it'll say passed, and then you can move forward with running your batch of 16. Even though you might be running 2 trays of 8, as long as you run them consecutively, one after the other, you only have to proceed a batch of 16 with one set of 4. You don't have to do 4 verifications for each tray of 8. You just have to do the 4 verifications for each batch of 16. So these, when we give you this presentation, we go through a little bit of pain to just keep re-emphasizing the name of the sample, the sequence, the location of where it goes, and keeping up with the batch number and the sample number in the sequence table, so that when we do process the data, we know exactly which sample it is. Those of you that haven't done a lot of ILSs, there is what we call mapping, so that your sample number is random. Your 17 is not the same as my 17, so we really need you to keep track very precisely. From the label of your ampule, the label has the sample number, and to be able to keep track of that. Dan, does the labels have the batch numbers on them also? They do. So. Yeah, so that's going to help you even more. You don't have to remember that number 20 is going to be batch 2 because the first 16 are batch 1 and the second 16 are batch 2. So I'm kind of jumping through this. If you have 8, which a couple of you have mentioned, when you're done, you're going to have a ILS samples folder that looks like this. You'll have the first batch as 2 directories, 1 through 8, 9 through 16, and so on, and the last batch only has 6. And then you'll have 1 verification samples for each batch also. Remember, this is in your ILS samples folder, which is separate from your sequences and methods and your system validation. Now, if you have a 16 tray, you would only have 4 of the ILS samples, 1 through 16, 17 through 32, 33 to 48, and then the last one. But you would still have 4 of the verification samples. If you have a giant tray, you're only going to have 1 subdirectory because all of your samples are going to be run in 1 pass. So again, a lot of detail on that. We ask that you don't process anything in VUV Analyze while you're running acquisitions. There's a slight chance on older computers that that there's a resource contention that goes on, meaning that the computer can't process VUV Analyze and still maintain that 4.5 hertz rate as a deterministic timing. So when you've completed all your runs, now recall, since I think everyone here on this meeting has a tray that's either 8 or 16. Of course, you'll be processing VUV1 for the response at each batch, at the start of each batch. But once you've acquired all the data, we want you to go ahead and process them. So let's look at that live. We've done all this work. We calculated the response each time we started a batch, so that's once a day. And then when we're done, we use Control-Shift-P. Keep in mind all these keystrokes are in the presentation, so you don't have to memorize them. We just ask that you come in and process your files. So, for example, all you have to do is open VUV Analyze, go into production mode. There's no work to be done. You don't have to load anything. You don't even have to load a production file like you used to have to do in previous versions. So then, let me pull over here. What we ask you to do is the following. We'll use the example. Now, I moved these out of the way because I wanted to make it a little easier. But this is probably what most of you will see. As I mentioned, if you only have a 16 slot, if you have a 16 slot tray, there'll be half as many of the ILS samples. But all you have to do is drag your folder in and hit Analyze. I won't now. Primarily these are empty, so nothing would happen. But if they were full, it's just going to take a few minutes, more than a few minutes, but it's going to take, 8 or so minutes, 8 to 10 minutes to process all the files in there. So you'll process those, come back, process the next, And when you're done, you don't have to process the verification samples. When you're done, the report files will be in a reports folder inside each of the folders that you've run. So this is one I just kind of threw together. I know there's only 5, you would have 8, but inside here you would have, your 8 reports. So all we're asking is that you process those files by batch processing. All you do is you drag it in, you hit analyze, walk away, come back, drag the next one in, analyze, etc. And then when you're done, go through each one of these to make sure that the reports folder has either 8 or 16, or for the last batch, 6 report folders. Then when you're done, you can just zip. Now you can see here I'm using some crazy zip application. You'll probably have your standard Windows one, and you can just send to compressed zip folder. It'll zip all the files up, and then you can load them into your respective company named box folders. I was going to see if I have that open here. No, I don't. All of you should have received an invitation to a box folder. If you do have troubles, give us an email. We'll get that sorted out. If for some reason you just can't use our box folder due to your IT restrictions and things of that nature, we can, on a case-by-case basis, arrange for some other method for loading that zip file into the web somewhere. So that series of slides goes over what we just talked about, the emphasis being running the 4 verification files and then running your batch and doing that, processing the data, zipping it, and sending it to us. If you did have a large tray, you would make one gigantic sequence, and in the end you would have just one folder, and you would batch process that one folder. We go through a lot of pain here to show you the naming convention with the batch number and the sample numbers, or being clear that you're using the blank or the RT or the CS or the VUV1. And in the end, we talk about zipping the folders. So this concludes the ILS presentation. It seems relatively straightforward. I didn't think it was going to take this long, but when we got into it, there was a lot to talk about in detail-wise. But the process itself is somewhat straightforward. You're doing acquisitions. You're being mindful of your naming in your sequences, and in the end, you're using the simplified version of VUV Analyze or VUV Pleon Plus setup. And we've simplified the process here, so at most you're doing is loading the library, loading your RT and your VUV1 file. Even though we have this portion here that is pretty intuitive, you would be analyzing the check standard. This will not be used until after the ILS. Going forward, when you're actually using the 8071 method, you'll be able to use the check standard to make sure your system response is working properly. So I'm going to open up to any questions at the moment. I know we went over quite a bit, so if you don't get any questions here at the moment, we're always available via email. Dan, do you have any?
Oh, pardon, Mark.
Yeah, go ahead, Federico.
A quick question. Which is the deadline of this project? Which is the deadline date that I have to upload all the data?
We would like to see it all by November the 1st, but I imagine there might be 1 or 2 labs that might be a week after that.
Okay.
So it'll take 4 days if you're running on small trays. We thought through the process you would come in the morning on the first day, validate the system, run the first batch, and then each morning you would run the 4 verification samples and then run the batch. So it would take 4 calendar days to get through all those samples, unless you're running a night shift. If you were really dedicated and you were willing to come in at night.
Yeah, Mark did say he was available day or night for questions, so.
Let's see, there's a question. Yeah, sorry, Dion has a question. Do you want us to analyze the samples after all of them have been ran, or analyze them after each batch of 16? So we set it up to analyze all the samples after, because you're not going to really, I mean, you can look at the results if you want to, but they won't make any sense, and we won't look at it because they won't make any sense to us. We're passing them on to ASTM. But Dion, we are asking that you analyze the VUV1 each morning prior to running the batch itself. And that's just to make sure that the response comes in. And the reason with that is we felt like the biggest concern could be moisture permeating the GC or the system overnight after the batch ends. See, here's another question. We're looking at the, Todd, we're looking at your ETOH validation. I think the ETOH was fine. Your CS2 showed a slight variation at the high and low end. So unfortunately I was out of the office this week, but we're going to look at that, and what we'll probably do is send you an updated coefficient to use. Since it wasn't a linear offset, we can't just add a number to it. Many of you all have seen where we look at the wavelengths, and usually it's a DC offset from shipping vibration. So that's where we are, Todd, with that. I'd been off-site, so we hadn't processed your CS2 file. But the ETOH looked great, and your counts are very nice too.
Mm-hmm.
So I'm going to ask if you all want to. We've got, I would like to take maybe about 15 minutes at most and just show you a few new features just to kind of pique your interest in some of the other changes in VUB Analyze that you haven't seen.
So I think this is one of the real benefits of participation is access to this new version of Analyze, which is got some very good reaction to it.
So if you hang up, I won't be offended. But and while we're going through this, if you think of a question that you didn't ask earlier, feel free to put it in there. So Control Shift R or Control Shift R. Let me try that again. Control Shift R brings us back to a familiar scene here. And I'm going to go ahead and, oops, let me back up. So the library file, the library file is here. The report method is here. What the heck's the report method? Where's my RRF? We're going to look at this in detail. The retention index file is the same as it has been, but you see now, even if you're not doing D8071, you can still process your RT file and have those values, and you have this file, the one we ran, was put in here. And so before I put in a run file and run it, and before I talk to you about why we don't have an RRF anymore, let's look at this little guy up here. Previously, this was a very small plot. First thing we've done is we've added in so you can resize it and you can move things around. Crowd goes crazy. The next thing we've done is we've put this little gear box up here. When we used to use it, let me see if I can, let me close it and I'll come right back, I promise. When we used to use it, we would go up and down, and you could turn things on and off, and then the colors were always changing and resetting. It was just a nightmare. But now you can come here and you can go to town on setting up the look of your plot the way you want it to see. You can look at turn on and off specific filters, change their color, their size, report items, meaning your classes or your speciated or your little groups of speciated. As you recall, our xylenes is actually a group of M, P, and O xylene. The error metrics, chi-squared or R-squared, and also the fit status. So these can all be set, color and size, and they'll be persistent, they'll be permanent until you change it again. Here we can update the axes, the number of digits of precision, showing them or not, auto-scaling them or not, grid lines if you like the colors, if you want to see them or not. And you'll see everything that you do is here. And when you're done, you can commit the changes. Or let's say you went through here and you changed a few things, and you said, oh man, I don't like that. You can just revert back to your last change. So it basically maintains one memory of what you want to see. So I can export my plots if I wanted to. I could save the image here that I make. Maybe I'm working on a report. I really don't want to change what I see, but I want to have a report that shows some specific analysis that I'm looking at. So you could save that image. So I won't go into all the detail here, but you can see it's quite involved, so we can see what's going on here. So the next step, the report method. Well, first off, some of you have done a lot of work on your RRFs, and even though it's painful, it's important to keep. So you can load your RRF in here. You don't have to load just an RM. If you were to open it, I'm hoping I have one here. Here's an RM, but if I wanted to load one of my RRFs, I could change it to all files, and if I could find one in here somewhere, I could prove it to you, but you'll just have to take it on faith that you can load your RRF files, and you could work with them. But here we've added this Edit Create button. So no longer do you have to battle with a text file. Here's the one I loaded. Maybe it was my RRF file that I loaded. That's fine. It'll take all that data and show you what you have here. The categories, the items that are in the category, and then the label itself. So here, xylenes was these three individuals. I could even take xylenes and add it to methylnaphthenes and create a new group if I wanted to. Let me open. I can keep it locked so I don't accidentally mess it up. I can unlock it so I can add stuff together. Let's say for some reason I wanted to add in isoparaffin 1115. I just add it over. I can give it a label. There it is. Let's see. Off the top of my head, I can't remember how to show you how to merge these two into one group if I want. Nonetheless, we'll have more detail on it. I want to just walk you through it and show you I can move items up and down. I can unselect them, select it all. I can delete them out of my list. This is the library here on the left side. Oh yeah, here we go. Here's how categories. So if you make a category, you could add, I think you can add both of them together like this. Add grouped items. Add individual items. I haven't done it too much. I thought we could multi-select them. So bear with me, but you can make categories and add them on, and you can sum them together. Maybe this is what I'm thinking of here. Yeah, where I've taken all four of these, and I've added them together, and I'm going to call them Mark's group. So you can group individuals, or you can group groups. So let me hit cancel here. What you're seeing here is xylenes is a group I made, and then methylnaphthenes, naphthalines is a group we made, and we can group those together too, and give it a name. So you have a lot of depth and flexibility to it all. I'm going to remove that, not that this matters for what I'm doing. The retention factors themselves have all been scrubbed in the new version of the library that we're talking about. They've been validated, and so you don't have to keep track of them. You don't have to go look them up. When you add an analyte over, you automatically get the retention factor put in. Now, Todd's
Response factor.
Yeah, excuse me, the response factor. Todd was asking a question. This is where you would say, add 1 butane and N-butane and just call the group total butanes. Yes, exactly. So, or dienes or other things like that. And you can see it's pretty extensive library. So I'm going to leave the detail at that. You can lock and unlock, and you can save it. I'm just going to close.
I'll just add that if you do have a compound that's not in the library and you have that compound, you run it, you define the spectra in Vision, and then you can add it to the library.
Very nice. See, you can take the library, the Piona library, as we're calling it, or the Analyze library, and add it in Vision, and then that'll be available for you in Piona.
For the advanced user.
Yes. Well, you're all advanced users. So that's pretty cool, but let's look at the results here. So I'm going to go ahead and run just above 1, because that's all I have available right at the moment. That matches the RI file. I want it to be relatively accurate. This hasn't changed much. They have, let me rephrase that, they have made some, we've tightened up the algorithm to resolve some issues with baselining that we had and with peak detection that we had. Here's our standard look here. We can view the report if we want to. We can export it to Excel. But here's the cool thing. Let's say I'm looking at C7, how about C7 aromatics? And I want to know, well, where did that number come from? Previously, it was a hunt and peck. You really had to look for it, but now you can just click on it, and it says, okay, well, for that cell, C7 aromatics, here you are. I'm going to click on snap to. Why that wasn't the default value, I don't know, but I want to snap to it, so then I just click on it, and it takes me right there.
Oh, nice. Very nice.
Yeah.
Yeah, see, the first nice.
But, oh, you know what? I really want to look at all the C10s. So here are all my C10s. I'll just go to this one, go to that one, go to this one. I can close that. As you might imagine, I just want to look at the aromatics instead. Here they all are. Oh, here's benzene. So we found this very helpful to go through. Maybe you're comparing it to DHA results or other types of results, and you can find out if you had some errors or whatever the case might be. So it's really nice now. There's one item I was going to show you up here, the chi-square limit. This will let you know that, yeah, you're getting a match here, but it's below the limit that we have. So no surprise at the beginning or in the tail or flat area near a peak that, yeah, you still might be getting just a touch of analyte there, but it's below the matching limits. We have the background. This lets you know if there's background available. You see it blinking up here. If you are looking at results for a peak and there's no background slices here, these slices are not identified as background, then you might question whether or not the matching is correct here or not. It means you probably have a very dirty matrix, but it's just a good analytical technique to understand why you are getting high or low results. If your background is being taken from a very different portion of the chromatogram, it could not be an accurate measure of the spectra here. We've done a lot of work to increase that so that the background is available in many places. And then we don't have, I'm not up to date on negative fit, so, but these status markers are quite helpful. Now, analyze one means, yes, we analyzed here and we found something. So it's no surprise to see in a very clean standard that we have background, we have a low chi-squared fit because you're just in the noise, and then we have analyze, and then back to background, low chi-squared fit, and then analyze, and so on. So it's pretty neat to have all of this here. So I think that kind of sums up the changes that we've made in this portion of VUV Analyze. Obviously, we have the setup screen and the production screen have been made easier. You don't have to keep track of a production file anymore. We still give you the ability to save your parameters. So if you're an advanced user doing work here, you have that. You can do some 8071 work here. This is very similar to the setup, so you have those tools available here. But for the purpose of the ILS, we got you completely out of this R&D area so you can just focus on acquiring the files in Analyze, in Vision, and then just analyzing them here and then moving into production to get the results. All right, gentlemen, so we've kind of